So far, you've done a great job with our new way of learning, with flipping the classroom. And tonight's lesson is a little bit more challenging. So you're going to want to make sure that you pay good, close attention, because we are finding the volume of composite figures in this lesson. You probably don't know what composite means. A composite figure, very simply, is a figure that can be divided into more than one of the basic figures. So we've already learned how to use a formula to find the volume of a rectangular prism. This lesson, we're going to learn how to add to find the volume of a solid figure made up of more than one rectangular prism. So if you take a look at this L-shaped figure that we have here, you notice it's L-shaped, and you notice that it has two different parts. And what we're going to try to do in this lesson is figure out how you can divide figures into two different parts in order to make finding the volume easier. So the first thing I want you to notice is this little dotted line right here. What they have done is they've shown you a great place to divide this figure. And if you look here, you see what they've done when they've divided it. It's made this figure here and then this figure here. So what we're going to work on is finding the volume of each of these figures individually, each of these solid figures individually. Okay, so the first thing we're going to do is we are going to look at, remember, volume is length times width times height. So we're going to look at the length first, and we're going to start with this figure, this first figure. If you'll notice, this entire figure's length is 6 feet. Okay, when you break it apart right here, your length of this first figure is obviously not going to be 6 feet because you've taken part of that away. Okay, what you do need to know is when we add these two together, the whole length is still going to be 6 feet. But what we need to do right now is find out what this length is. And I want to show you, if you'll look right here, the top. This 2 feet is telling us that that is the length of this smaller part. So even though it's not written right here, that is showing us that that's where the length goes. So what we're going to do is we're going to bring the length down here, and I'm just going to write, so that you see it, 2 feet. So we know this whole thing right here is 6 feet, but where this dotted line separates these two figures, this side is just going to be 2 feet. Okay, so I'm going to come over here and go ahead and mark that as 2 feet. Now, while we're doing that, let's go ahead and think about it. If this part right here is 2 feet, what would the rest of this figure be? The whole thing is 6, and this is 2. The other figure, or the other part that's left, would be 4 feet. So let's go ahead and put our 4 feet here. So we know this figure's length is 4 feet. Okay, so now we have the length of both of the individual figures that we have taken apart from this one huge figure. Okay, let's look at the width next. If you'll notice, the width does not change. Okay, it doesn't change. So both of these have the same exact width. And the width is kind of tricky to find in this picture. This is a width right here. Think about it. Remember, this is the length. The width goes this way, and this is the height. So that 2 right there really goes with the height. This is the length. This is the height. There's me a width figure right there. So we know this whole thing only goes back 4 feet. So both of our widths are going to be 4 feet. So I'm going to stick my width right here. It's kind of hard to fit it all in, but that's 4 feet, and that's 4 feet. Okay. Now, the last thing we need to do is height. If you'll notice, this first one's pretty easy because this is our height measurement right here, and it's obviously 4 feet tall. So let's go ahead and make this one 4 feet tall. Now, let's check out the height of this. If you'll notice, this is a height measurement. It tells us it's 2 feet, and you can kind of see the height of that is about half of the height of the other figure that's 4 feet. So our height here is going to be 2 feet. Now we can very, very simply figure out the dimensions of each of these figures, which is what it asks you to do right here. what would be the dimensions of the prism on the left? So that would be this one. This is on the left. Dimensions simply means what are the measurements. So the dimensions of the one on the left, let's do length first. Length times width times height. So the dimensions of the figure on the left are 2 by 4 by 4. By meaning times. Okay, 2 times 4 is 8. 8 times 4 is 32. I'm going to go ahead and just write this down so I can remember it, that it's 32. Remember that it's cubic feet, and that's something that you always want to put. The next question says, what would be the dimensions of the prism on the right? So let's do the same thing. Remember, dimensions are the measurements. So let's do length first. We have 4 times the width is 4 times the height is 2. 4 times 4 is 16 times 2 is 32 as well. So we have 32 cubic feet. How could you find the volume of each prism? Here's the cool part. All you do now that you have the volume is you add the two volumes together to get the volume of this entire figure. Okay? What is the volume of each prism? And you know what? I'm going to go back because back to how could you find the volume of each prism? I got a little ahead of myself there. How do you find the volume of each prism? Length times width times height. What is the volume of each prism? Here's where it's asking me that, and we know it's 32 square feet or cubic feet and 32 cubic feet. Okay, how could you find the volume of the figure made up of these two prisms? You add them together. So after you add 32 plus 32, you're going to get 64 cubic feet. So I know that this entire figure, this L-shaped figure, the volume of this is 64 64 cubic feet, not square feet. Remember, square is area, cubic is volume. Okay, this slide, I just wanted to show you just some different plane figures. We have plane figures on top. Remember, plane figures are flat. And these, you find the area. If you had a composite figure and you needed to find the area, this is just showing you how you could break these apart. This would break apart to this. They've cut it right here. This one, they've cut right here. Down here on the bottom, we have rectangular prisms. Same thing. Find where you could cut it apart, which would be right here for this one, to get two very similar figures. Pull them out, and it just makes it very easy to figure out the volume of rectangular prisms. Okay, let's take a look at this garden. Bethany is making a garden bed. The diagram shows its measurements. If she fills the bed to the top with soil, how many cubic feet of soil will Bethany need? So if you look at this figure right here, and you think about how you can divide it, there are a couple different ways. The first way they're showing us divides it right through here, and you can see that right here, so that you have a rectangular prism back here, and you have one right here. The prism that is right here, if you notice the measurement, the length is 6. That's very obvious. It's marked. The width is also marked 4. The height is 2. So this one's very obvious to figure out what the measurements are. So this is 6 by 4 by 2. 6 times 4 is 24 times 2 is 48. The second prism, okay, when you look at the length, not only does it just go to here, but it goes all the way to the end. Look, it starts right here and goes all the way to here. So it's more than just this 6 feet in length. Remember, the length of this was 6 feet too, so we basically put these two together. So the length of this rectangular prism is 12 feet, okay? The width is still going to be 6 feet. And the height right here that's 2 feet, it's the same. It's still going to be 2 feet. So this second rectangular prism would measure 12 by 6 by 2. Okay, So when you got the measurements, when you got your volume figured out, you would just add those two together to get your complete volume, your total volume for this entire figure, just by breaking it up in that way. Okay, so on the last slide, we looked at breaking this rectangular prism up this way, or this figure up into rectangular prisms this way. But you can also break it another way. And this way, instead of doing the dotted line here, they did the dotted line here. Okay, so if you look down here at this figure, let's see if we can look and understand the different measurements. It says one prism measures 6 feet by 10 feet by 2 feet. All right, 6 feet is the length. Where did they get the 10 feet? Okay, look at this. This goes all the way back. The width of just this part is 4. But because it goes all the way to the back, we also have to add the width of this. So 4 plus 6, it's really 10 feet wide. And then the height is 2, and that doesn't change. The other prism, so we're talking about this one right here, the length of this is just 6 because it's just this part here. The width is just 6 because it's right here, and then the height again is 2. Remember that here's your height measurement, and it's the same. So we have 6 by 10 by 2 for this figure here, and then we have 6 by 6 by 2 for this figure here. When you get the volume of each of these and you add them together, you will have the volume for this entire figure. Okay, let's look at this problem number 7 as just a word problem and see if we can figure out what to do from there. It says the recreation center has an L-shaped pool. So this is L-shaped, so you could pretend it's this. This is not the problem that goes with 7, but just pretend it's an L-shaped pool. One part of the pool is 8 meters by 6 meters. The other part is 12 meters by 6 meters. Okay, those are the two measurements that we have for each of the parts of the pool. The whole pool is 4 meters deep. What is the volume of the entire pool? Okay, so in order to figure that, we need to figure the volumes of each part first. The first part says it's 8 meters by 6 meters. Okay, and we know it's 4 meters deep. So here's my length, my width, and my height, or my depth. This one would be more depth. So we have 8 times 6 is 48, and 48 times 4, let's see what that would be. 48 times 4, 4 times 8 is 32, 4 times 4 is 16, plus 3 is 19. Okay, so this first part would be 192 meters cubed, or cubic meters. That's the first part of the pool. The second part of the pool is 12 meters by 6 meters, and it's still 4 meters deep. Remember, when we're looking at volume, you've got to have those 3 measurements unless there's an area that's already been done for you. 12 times 6 is 72 times 4. 72 times 4. 4 times 2 is 8. 4 times 7 is 28. So the volume of the second part of the pool is 288 cubic meters. It asks what is the volume of the entire pool. So I'm going to add them together. 288 plus 192. 2 is 10, 18, 480. So my answer would be 480 cubic meters. Okay, let's try another one. The diagram shows the shape of a cement walkway. What is the total volume of cement needed to make the walkway? Okay, as I look at this problem, I think the most logical place to draw my line would be right here. So I've made 2 different rectangular prisms. Okay, so let's look first at this one, and let's look at the measurements. So I know my length is 2 feet. I know my width is 10 feet, and here's my measurement for width right here, 10 feet. So 2 times 10 times my height. I don't see any height measurements over here, so I'm going to look on the other part of the shape, and I see that this is where we typically see height. There's my height measurement. So 2 by 10 by 1. 2 times 10 is 20, times 1 is 20 cubic feet. Okay, so I know the volume of this shape right here is 20 cubic feet. Okay, let's look at this shape now. Let's look at the length, the width, and the height. The length of this is what? What would you say? This is where it gets a little bit tricky, okay? So this is a length measurement on top. Remember, these are like, this is length, this is length. This whole thing is 8 feet, but I've sliced it right here, so I don't get the whole thing. I have to take away this amount of length, 2 feet. So 8 minus 2 is 6. So the length of this part that's left is only 6. Think about it. If I added 6 plus 2, I'm going to get 8. So I have 6 is my length. My width is still 2. Okay? My width is 2 here, because this is just a portion of the 10 feet in width here. This one, they gave us that it was 2 feet wide, so 6 times 2. And then the height, you look at the height doesn't change. The height is 1 foot. It's 1 foot all the way. So we have 6 times 2 is 12, times 1 is 12. So we have 12 cubic feet. Now, in order to get the total volume of cement that they need, we have to add these two together, because they obviously have to have cement for this and they have to have cement for this. So when you add together 20 plus 12, you get 32 cubic feet. Okay? Okay, this problem is a little tricky, so listen closely. Workers are replacing some square pipes at a gas station. Notice the word square, that's kind of a clue. Remember, a square, all the sides are the same size. The sides of the pipes are 2 inches long. One worker joins a pipe 48 inches long to one that is twice its length. The pipes do not overlap each other. What is the total volume of these two pipes joined together? So let's just take one pipe at a time. If we know it's square pipes, we know that 2 of our dimensions in volume are going to be 2 inches long, because if it's 2 inches, you know that it's going to be 2 inches on all 4 sides. So we know you're going to have 2 times 2. Your third measurement is one worker joins a pipe at 48 inches long. So that's going to be our first one. 2 times 2 times 48. Okay, that's one pipe. The other one is going to be 2 times 2, because still we're doing square pipes and they're 2 inches long. So we know all the sides are 2 inches. 2 times 2 times, it says one worker joins a pipe 48 inches long to one that is twice its length. What is 2 times 48, or twice? 96. Okay, so if you multiply these out, you have 4 times 48, which is 192. And you have 4 times 96, which is 384. Okay, so these are cubic inches. So the first pipe is 192 cubic inches, and the second pipe is 384 cubic inches. It wants to know what is the total volume of those two joined together. So when I add 384 plus 192, I get 576. So I know my answer is D. All right, I feel like this problem gives us lots of good information. A pool shaped like a rectangular prism is 40 feet long, 20 feet wide, and 4 feet deep. Look at that. We have all 3 dimensions already. Attached to the side of the pool is a hot tub with 1/4 the volume of the pool. What is the total volume of the pool in the hot tub? So hopefully you're seeing there that we have a pool, and here are the dimensions of the pool, 40 by 20 by 4. Then they've attached to the side of the pool a hot tub that's 1/4 the volume of the pool. So let's figure out the volume of the pool first. It's 40 by 20 by 4. And remember how we can do 40 times 20. 4 times 2 is 8, and there are 2 zeros. So 40 times 20 is 800 times 4. 4 times 8 is 32 plus 2 zeros. So we know that the volume of the pool is 3,200 feet. Okay, cubic feet. They've attached to the side of the pool a hot tub with 1/4 the volume of the pool. Okay, so 1/4 of something tells you it's 1/4 times something. Okay, so another easy way to do that is to find 1/4 of 3,200. You just divide it by 4. 4 goes into 32 8 times. And your answer is 800. So 1/4 of 3200 is 800. So now we have to have the total volume. So we're going to add these two together. 3200 plus that hot tub, which is 800, becomes 4,000. So we have 4,000 cubic feet. Okay, last page. I know this has been kind of a heavy lesson, but you've got to really just stop and think when you're trying to figure the volume of composite shapes. Think about what was taken away. Think about what is left. Notice where your measurements are as you go around your figures. I'd like on your lesson notes page for you to figure for me the volume of these 3 composite shapes. Going back and using the information that you had in this lesson, you're going to need to cut probably in order to figure out what your measurements are going to be for each part. But remember, when you're finding the volume of composite shapes, that you need to split them apart into 2 rectangular prisms, figure out the volume of those, and then add them together. Sometimes you'll hear it called additive volume, where you've added 2 different volumes together to get the volume of a total composite figure. Come tomorrow to class with any questions that you have, and we will be practicing this because I do know this is kind of difficult and it just takes practice. The more you practice, the easier it becomes. Have a great evening.